Hi all. In this video we will go over Snell's law. So we should remember first what the index of refraction is. It's defined as the ratio of the speed of light in a vacuum divided by the speed of light in a medium. And we also need to remember, or not necessarily remember, since you haven't learned this yet. However, for a wave, the velocity of a wave is going to be equal to the wavelength times its frequency. So another consequence is that the index of refraction in one medium times the wavelength, and that medium is going to equal the index of refraction in another medium times the wavelength. And the reason why is because the frequency never changes. So now what we can do is we can look at Snell's law. So what Snell's law is that the index of refraction in one medium times the sine of theta relative to normal in that medium is equal to the index of refraction in the other medium times the sine of theta 2 in the other medium. That's relative to the normal. So if we were to look at, say, water, so this is a surface of water, and inside here is water. We'll say outside here is air. So n equal to 1 in air, and then let's say n is about 1.3 inside the water. So the way you go about solving a Snell's law problem is you first need to define the normal to the surface. So it comes in as such. And now we will draw a incoming ray. So ray of light will come in this way. And it'll leave like that. So this is theta 1, and this is theta 2. So we can find that using Snell's law, n1 sine theta 1 equals n2 sine theta 2. If we want to solve for, let's say, sine theta 2, then this is just sine theta 2 equals n1 over n2 sine theta 1. And then we would just put in values, and you'd have to probably be given this theta 1. So one interesting thing you can do here is you can see that it's bent more once you go into the air. So there will be an angle of incident such that if it hits, then it will be totally internally reflected. So this angle will be theta 1 critical, and then this angle is just 90 degrees. So anything larger than that, so say it's even larger, and it's just going to bounce off and come back like that. So we could solve for that and have it be, since we're trying to solve for theta 1, sine theta of 90 is 1, so we'll get 1 equals n1 over n2 sine theta 1c. So we can just multiply that over. We'll bring this all the way up here. So we get n2 over n1 equals sine theta 1 critical, and then theta 1 critical equals sine inverse of n2 over n1. So is this possible? In our case, the sine of, let's see, sine, we're saying this is 1 and then this is 2. This is 1, this is 2. n2 is going to be 1 and n1 is going to be larger than 1, so this is a number less than 1. So yes, it is an angle, and theta 1 critical will be approximately sine inverse of 1 over 1.3, and that should be a number around 50 degrees. All right.